Okay, good morning, everyone. And I know that we don't have a lot of people on right now, but we are recording this Blitz. So if you missed it, you can follow along with the concept. Today you have a pretty basic proof that we're going to introduce. And I'm going to, before I get into the actual proof, I'm just going to share with you the reason why this works. So I'm going to start by using my calculator here. I press menu. I'm just going to insert geometry here, and then I go menu, shapes, and a circle. So here's a circle. I'm going to place some points on the circle. So just 4 points anywhere on the circle will work. And what we're doing is we're inscribing a quadrilateral on a circle. So if I go in here to shapes and I put the polygon, quadrilateral means 4 sides, cuatro lados, quadrilateral. So a 4-sided polygon that is written upon, inscribed upon the circle, right? And so now, it doesn't matter how, this doesn't have to be a special kind of a quadrilateral for this to work. This can be just like any quadrilateral as long as all 4 vertices are on the circle. And what we're going to see is kind of interesting here. We're going to see that this measure of any 2 opposite angles, any 2 opposite angles here are going to be supplementary. Okay? So what that means is that, if I add together the measure of one angle with the other angle, right, it should equal 180 degrees. And I'm just going to put in some text to kind of prove that. This is a demonstration right here, not really a proof. But if I said, okay, what is A plus B equal to, right? And now I'm going to measure one angle. So I'm going to take the measurement of an angle here, and I'll measure this angle right here. Okay, and then I'm going to take the measurement of the opposite angle over there. If I add those together, what does it equal? So what we'll do is we'll let the computer or the calculator compute that answer using calculate. We calculate this expression using this value for A and this value for B. Tells us that it adds up to exactly 180. And now we get a chance to really see if that's always going to be true, right? So if I move this point around, you can see the measure of that angle is not going to change. That's interesting, and we'll have to think about why that is. And if I move this point around, also its measure does not change, and we'll think about why that is. What if I move this point? Well, then they both change, but you notice that it's continually adding up the total, and the total isn't changing, right? If I do something like that, then it changes. And then we don't have a quadrilateral. But if I stay here, you can see it's constantly calculating the sum of those 2 angle measures. And as long as it's a quadrilateral, you can see that even though those angle measures change, when one gets smaller, the other gets bigger, and they remain supplementary. So now the question is, why does that happen? And then that's what you need to know in order to prove this here, is you need to know, why is this happening? So what we'll do to show why this is happening is that we will explain the relationship between this angle and what we call its intercepted arc. Okay, so, and let's go over a few things here real quick, right? Let me get a text tool out here, right? So just to remember, an arc is a part of a circle, right? And then another thing we'll put in here is an inscribed angle is an angle with vertex on the circle. Okay, so now the relationship is this, right? And I'm going to zoom out a little bit, just a teeny bit. So let me hit view. And oh boy, that's not what I wanted. Menu, view. Let me go to, I'm going to go back to, where's my zoom? Hold on a minute. Let me hit escape here. Escape here. I did not want to get into the graphing view here, so let me Control Z and get back there. Menu. Sorry about that. View. Well, how do I zoom? I forgot how to zoom here. Okay, it doesn't matter. Let me hit escape. Sorry about that. It has something to do with this here, I remember, where you No, I don't know. I can't remember. Anyway, the idea is that this is an inscribed angle. And if I follow the sides of the angle, I can see that the sides intercept the arc. So this side goes here, intercepts the arc. This side goes here, intercepts the circle. And the 2 points, which are these vertices of the quadrilateral, separate the circle, right? So that this is one arc here, and this is the other arc there. And it turns out these two angles that are opposite each other in this quadrilateral, they have arcs, right, that together make up a full circle. So now I want you to watch this. Let's see if I can get this running here real quick. Then you're going to see what I'm going to do with my proof. The relationship between the arc, this arc right here, right, and the angle, the inscribed angle, is that the angle is 1/2 the measure of the arc. So let me see. Hopefully you can see this okay. What I've done is I've created a little circle here, right? You guys see that all right? Judy, can you see that okay?
Yep, it's perfect.
Okay, so you have a circle here, right? I don't know, maybe I'll call this circle O right here, okay? So circle O is made up of 2 parts. In orange, I have an arc that's called ABC, arc ABC. And I want you to see that it has a relationship to this angle D here, because angle D is made up of orange also. It's really could be called angle ADC. So the relationship between arc ABC and angle ADC is that this is the arc that's formed by the angle when the angle intercepts the sides. See where D goes to A, that's where the arc begins. And where D goes to C, that's where the arc ends. And so this angle is related to this arc. And it turns out that the measure, whatever this arc measures, this angle is going to measure half. That's going to measure half. This measures half of that arc. So then I have the rest of the circle. If you look at the rest of the circle, it's shaded in blue. And its measure is half of its intercepted arc, which is ABC. So now what do we get when we add the orange and the blue together? Right? So that would be arc ABC and arc CDA. And when I add them together, it's the whole circle. So it measures 360 degrees. Right? And I know from what I just shared with you that the measure of angle B, right here, B, this measure of angle B is half of the measure of its arc, the blue arc, right? And the measure of angle D, this orange angle down here, D, is half of its arc, right? So if I know that together the arcs measure 360 and half of their measures is half of 360, then I know that by substitution, instead of writing half the measure of CDA, I can just write measure B, right? And instead of writing half the measure of ABC, I can write D. So therefore, adding together the measure of angle D and the measure of angle D, B and D will give us 180 degrees, and therefore B and D are supplementary. And they are always supplementary, as we just showed to you. So this right here, this is the entire proof right here. As long as we know that the 2 arcs together create a full circle and measures 103 or 360 degrees, and we know this fact that the measure of an inscribed angle is half the measure of its intercepted arc, right? We know that fact. The measure of the inscribed angle equals half the measure of its intercepted arc, and half of the measure of those arcs together is half of 360 or 180, right? Then the measures of the angles has to always add up to 180. Therefore, they are supplementary. That's the entire proof that you need to post. I'm going to put it on. I'm going to put it on our Google Classroom. I'll put it on our Flipgrid and then post it all to Google Classroom here within an hour. What questions do you guys have? It's just me, and you, Judy, huh? Has anybody else been on? Doesn't look like it. Okay, well, that is it. A very, very quick blitz then with no questions or anything. I'm going to go ahead and I'll stop sharing. And I'm going to stop recording, and then this will all be shared through Google Classroom. Thank you very much.